So we want to solve equations, right? Solving trigonometric equations. The process here is a lot like solving radical equations. You want to get the trig function on one side by itself, then you're going to apply an inverse trig function to get rid of it. All right, so look at this thing, right? What I'm going to do here, I'm going to take the inverse cosine of both sides, inverse cosine of the cosine of theta equals the inverse cosine of -1. So theta equals the inverse cosine of -1. Now I'm not going to stop there. I'm going to want to turn these into angles, right? So what angle has a cosine of -1? Well, that's going to be pi, but that's not it. More than that, right? Remember that this function is periodic. I can add 2 pi to this over and over again, and I get more, right? So 3 pi is a solution, 5 pi, and so on. And for that matter, let me make a little room here. I can add in the negatives. Negative pi, -3 pi. There's a lot of them. Okay, so how am I going to write this? Right, because I want to simplify this. I want to make this into something that's smaller, easier to read. Well, think about what's going on here, right? This is x equals an odd number times pi. Right, you see that here. I've got 1, that's odd. 3 is odd. 5 is odd. -1, -3, those are all odd. Right, so these are odd numbers times pi. Well, how can we write an odd number? There's kind of a formula for an odd number. I'm going to write this 2k plus 1 pi, where k is an integer. Right, so you try it out if you don't believe me, right? Let k be 0. When k is 0, 2 times 0 plus 1 is 1. That's pi. When k is 1, 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. 2 times 3 plus 1 is 7. I'm getting all the odd numbers there. All right, so you really need to take a minute and think about this notation here, right? Because that's how we're going to be writing a lot of the answers throughout this whole section. All right, so let me give you one. Right? Try this one out, see what you come up with. All right, well, let's start off the same way. Inverse cosine of both sides. All right, well, this is theta equals, okay, inverse cosine of 0, pi over 2. Cosine of pi over 2 is 0. 3 pi over 2. 5 pi over 2. And we can go, I always forget to leave room. We can go into the negatives. Negative pi over 2. -3 pi over 2. And so on. All right, so look at what's going on here. Look for the pattern. What are these numbers? These numbers are an odd number times pi over 2. And how do I say an odd number? That's 2k plus 1. So this is 2k plus 1 pi over 2, where k is an integer. And there are my solutions. Okay, so how about this one? This one, there's going to be a twist here. Right? I'm going to start the same way. I'm going to take the inverse sine of both sides. And I get theta equals the inverse sine of 1/2. Okay, so an angle whose sine is 1/2. I'm thinking pi over 6, right? Sine of pi over 6 is 1/2. So theta is pi over 6 plus any even multiple of pi. Right? That's the periodicity thing. I can add 2 pi, 4 pi, 6 pi. Those are all still going to give me answers. Okay, so what I need to say here is even number times pi. All right, well, how am I going to say an even number? This is pi over 6 plus 2k pi, where k is an integer. All right, but that's not it. I'm not done. That didn't give me all of them. Right? And you notice I'm not limiting myself to the range of the inverse sign here, right? Just like when you're taking the square root of both sides of an equation, you no longer just look at the positive ones. I want everything. So I want you to think about this for a minute. Give me an angle other than pi over 6 plus a multiple of 2 pi, whose sine is 1/2. All right, I think about this for a minute, 5 pi over 6 also works. Sine of 5 pi over 6 is 1/2. All right, so there's another set of answers here now, right? Also, I have to include 5 pi over 6 plus an even number times pi. All right, and I'm going to say an even number exactly the same way that I did before. Let me make a little room. So I'm going to say pi over 6 plus 2k pi, or 5 pi over 6 plus 2k pi, where k is an integer. Now I have all the answers. Okay, so how about this one? Take this one and see what you come up with. Don't be put off by that x plus 1, right? You're just going to subtract 1 at the very end. So try this and see what you get. All right, so let's take the inverse cosine of both sides. So that gives me x plus 1 equals the inverse cosine of the square root of 2 over 2. Okay, so let's see. X plus 1 equals an angle whose cosine is the square root of 2 over 2. We'll start with the easy one, right? Pi over 4. Pi over 4 plus 2k pi, right? Because every multiple of 2k pi we can add on to that, and we have the same cosine. Comma, what else? What else? Well, how about negative pi over 4? Right? Negative pi over 4 also has a cosine of the square root of 2 over 2. All right, so let's put that on here. Negative pi over 4 plus 2k pi, where k is an integer. Okay, but now I got to deal with that plus 1, right? Well, look, just subtract 1 from both sides, just like we always do. Just do it from both of the solutions, right? So x is pi over 4 minus 1 plus 2k pi, or minus pi over 4 minus 1 plus 2k pi, still where k is an integer. And there you go. There's my answers. Okay, so that's our new twist, right? Our new twist here is you have to make sure you're getting all of the answers. And 0, 1, and negative 1 are kind of special, right? Because there's only one value usually. There's only one angle that's going to give us those particular values, right? Any other number, you have to be aware there's going to be 2, right? And then you're just going to do this plus 2k pi business, and you're home free. All right, so this isn't, we need to do some more. There are some other things that can happen that can come up with these. So in the next lecture, we're going to look at some more examples.